Welcome, everybody. Assalamu alaikum and a good afternoon to all of you. I hope everybody can hear me. Okay, today we have a very interesting topic today: innovative methods for long life concrete waterproofing protection against water ingress and rebar corrosion. Okay, before that, I would like to take this opportunity to thank the sponsor of this talk, okay, Kimmo, and we have a very distinguished speaker today, all the way from Australia, okay, Mr. Michael Rorke. Now, before I go into further details, all right, all your Q&A, please put it into the Q&A chat box and not the chat box. Okay, so just a reminder of this. Okay, Q&A, put all your Q&A inside the Q&A chat and not the chat group. Okay, let's go straight into this talk. Okay, with that, I would like to introduce Mr. Michael Rorke. He is the Managing Director of Concrete Waterproofing System, Sydney, Australia. So good afternoon to you, Mr. Rorke. Okay, Mr. Rorke, Mr. Michael has been in construction for a very long time, over 30 years to his credit. Okay, he is a former swimming pool constructor. Okay, a building and innovating over 400 swimming pools. So that's a lot of water there. Annually, wow, that's even worse. That's even much good. Okay, Michael moved in to exporting of construction products, mostly technological advanced waterproofing materials. Over the last 20 years, over time, he has provided a solution to the international clients' need, especially in the demanding commercial buildings, top-tier property development projects, and complex infrastructure. And not only in Australia, but over 50 countries throughout Asia, Europe, the Middle East, Africa, North and South America. I wonder when he'll go to the Antarctica and the Arctic. Not much construction there, but who knows? In future, he will do that. Besides that, he is a licensed commercial pilot. Now, that's something interesting, isn't it? Okay. And I wonder how many times he broke the lockdown with his pilot and aeroplane. Okay, then he has been nominated Exporter of the Year by the Master Builders Association in Australia. So quite a repetition here. So I'm sure that the following talk will be just as interesting, if not very, what do you call it? Yeah. Okay, so without further ado, please, Michael, over to you then.
Okay, thank you very much, Architect Zarim. I appreciate your very kind intro. So, good evening, everyone. As Architect said, my name is Michael Rorke, and I'm the Managing Director of Concrete Waterproofing Systems. I'll just share the presentation with you now, and I'm hoping you can all see that. And this is the topic for tonight: innovative methods for lifelong concrete waterproofing, as well as protection against water ingress and rebar corrosion. So I'll just give you a second now to scan this QR code if you'd like to do so. While you're doing that, I would like to introduce our very good friends at Kimmo, who represent us in Malaysia and do an excellent job of doing that. And if you scan the QR code, they will send you a seminar kit in the next little bit. I should also introduce our international marketing manager to you, who you may not be able to see, but he's present. His name is Mr. Fanis Lekis, who's based in Europe. And so if you missed the code, don't worry, there'll be another one at the end. So let's get into the presentation. Oh, and it would be amiss of me not to thank Miss Karma, who set up the, all this presentation for me. I'd like to say a thank you to her as well. So let's now have a chat about the topic of the evening. And look, the first, say 4 or 5 slides is nothing that you don't already know, okay? It's just a bit of a recap to set context, that's all it is. And then we'll move on from there. Now, let's look at the consequences, the problems and the consequences of waterproofing as it is today. Now, you get leaks into a building, you obviously get equipment damage. We've given the example of a hospital. You get leakage in a hospital, all that equipment's worth millions and millions of dollars. You've got some serious issues going on. The same thing with shopping malls and whatever. You can get suspension of activity. And I'll show you a slide later of one I saw not far from here. You then get into all the liabilities of tenant complaints. If somebody falls over, you get legal liability. If tenants want money reimbursed for having to close their shop, all this just goes on, which you know about, and the inconvenience. And if it is the inconvenience to everyone, and if it happens anytime, you know, soon after the product has been applied, you can get some of those problems landing back on your desk, which is not what anybody wants. So then you get to what I would call the unseen enemy, the really serious consequences, which is corrosion of the rebar. And as you know, once that starts happening, then you've got serious issues. You've only got to look at that recent thing in Miami, the building that collapsed. The initial finding was exactly that, rebar corrosion. Now, whether that's the final finding, we'll wait and see. But there's plenty of cases of this, lives lost, and there's serious consequences, and all the way through the supply chain. If that is the case in Miami, there'll be people going to jail for that. It's not a joke. So apart from the moral issue. So quickly, let's look at the factors that affect resistance of the concrete to moisture. Now, you've got the original design, which you guys take care of the concrete, the MPA strength, the ingredients, you know, whether you put fly ash in it, whether you don't, and the water cement ratio. So you're trying to design leak-free concrete, which is to some extent possible, but nobody can stop concrete from cracking. And that's a key point. Nobody can do that. And I'd like to quote you an engineer from Norway, an engineer by the name of Ivar Ness, who was the head of the Norwegian Bridge Department, who said, if you use concrete of 45 MPa or more, it's inherently waterproof, but nobody can stop it cracking, and therefore you get problems. Beyond the design, you've then got the situation of the actual contracting itself. Now, sorry, I'm Australian. I often say you guys. So with respect to the ladies, we just say guys in Australia. It encompasses everybody. You know yourself that you may design something, but it's not necessarily built exactly to spec. When the contractors go to pour a job, it might be a really hot day, they get stuck in KL traffic, and the concrete's starting to go off, they give it more water. They get on site, they give it more water to make it workable. All of a sudden, your workability, you've got workability, but your water cement ratio has gone out the window. So all those hazards of construction, so to speak, are there every day. And, excuse me, I would have suggested personally that most buildings are well designed, but are they actually well built? Not necessarily the same. And you've of course got environmental factors like weather, location beside the sea, and you might have freeze thaw in Europe and all the rest of it. and I'll keep moving, you know all this stuff. And then you get to the mechanisms affecting service life, starting right at the very start. From the day it starts, the concrete starts drying, you're getting shrinkage, cracking, and as you go on through the concrete over the next couple of years, you're getting further shrinkage, cracking, the effect of load bearing, the environment, chloride ions attacking the concrete. All this sort of stuff can affect the service life of the concrete, as you know. Now, governments try and regulate some of this stuff by having national building regulations. Well, in many cases, they're state-based. This is all in Europe, where it's a European code, where it's designed to regulate that. But there's only so much that regulation can do. Although I'm a bit cynical, if you look at the European regulatory authorities, they think they can sort it out, but I'm not so sure. So yes, you've got to follow codes and everything else. But then you get to the, as I said before, the unseen enemy, the corrosion of the concrete. When this starts happening, you are getting into really high risk territory. A little bit of corrosion is no issue, but it generally doesn't stop at that point. So now you've got serious potential issues in the building, depending on how far it goes. Now, one of the other things you can do to address this issue is actually waterproofing. You've done your mixed design and so on, and now you try and stop the entrance of water, chloride, or might be chemicals in the case of a sewage plant or something like that, getting into the concrete. So again, that is within your control as designers. So now let's have a think about what the options are that you've had in the past and what the potential is in the future. And I should preface this by saying, I've always personally thought in an idealistic situation that it's crazy that you designers, I'll keep saying you guys, please excuse me if I do, you designers design a building for 50 or 100 years, and yet the waterproofing going on it will typically last for 10 or 15 years, maybe less, maybe a bit more. It kind of doesn't make sense in a theoretical world, although we don't live in a theoretical world. So I would like you to sit back for a minute and think to yourself. So first of all, why do people do that? I think it's because they think they don't have a choice. That's the main reason. They don't believe they have any choices. It's not that they want it, they don't have a choice. What do you think of the traditional waterproofing methods, by which I'm obviously talking about various forms of membrane and whatever? What do you think of them? Now, if I asked you to tell me on a scale of 1 to 10, what number would you come up with? And look, I've asked this question at I did a similar seminar to this, except it was face-to-face in Jakarta a couple of times, about 3 or 4 years ago. And, well, I'm not trying to preempt what you might think, but most people went, it's okay, it's okay. Nobody was too excited, I've got to say that. And I think this is the reason. We all know that sooner or later, traditional waterproofing fails. It's not will it fail, it's when it fails. Now, that's not the fault of a designer. You can only use what products are available in the marketplace. But what happens here, this photo on the left, that's a membrane, that's actually up in Saigon or Ho Chi Minh City, where the membrane's failed on a bridge. You've done the one down in the bottom right, you can see another membrane lifting there. The result is water ingress into the building and eventually the corrosion of the structure, as you see there. So that's what happens. So here is an example. This is the one I referred to earlier. This is a major shopping centre in Australia. It's only a couple of miles from where I live, and I took this photo myself. This is one of the biggest shopping centres in the Southern Hemisphere. And you can see all the ceilings been pulled out because of the leakage, and there were buckets there on the floor. And this is a major retailer within that shopping complex. And the failure of waterproofing like this causes massive problems, which, depending when they happen and so on, can even affect the reputation of the specifier, right? We're all in this game together, and that is what can happen. So what happens then? They replace the membrane. So here, this is a job in Jakarta. And this is what happens. And you know this, so I suppose you've been through it yourself, most of you at some time or another. But by then the building's moved on and it's not your responsibility. So maybe you don't see it as often as I see it. We get lots of requests to do this. Jackhammer up the screed, as the guy's doing on the left. The guy on the right is pulling the membrane up and they've got to get rid of it. Now, this is up on the 25th floor of a building. So you need cranes to remove the rubbish. All this becomes landfill. Not a great thing for the environment. And I'll give you a couple of examples of that. When they built what was the new airport in Hong Kong back in the 97 or thereabouts, the waterproofing on those bridges out to the airport failed within 6 months. And it was dug up thousands of square metres and redone. Even KLIA, 7 years later, I think it was 7 years, don't quote me, but it wasn't that long, they were digging up thousands of square metres of membrane. Again, it all becomes landfill. It's costly and they have to do it several times. Now, again, you mightn't see it because the building's long since left your care, so to speak, but this is what happens. We see this all the time. So I personally, from a theoretical point of view, don't think that's the best solution. So the question I ask you is this: would it be nice to have problem-free lifetime waterproofing for concrete? Would it be nice? That's one thing. It probably sounds nice. And the next thing is it actually possible? That's what I have to ask you. Is it possible? Well, the answer is yes, it is possible. Now, we talked about innovation. Innovation means that problem-free lifetime waterproofing and concrete protection is a reality. And I want to emphasize a couple of things here. And by the way, somebody said to me today that I sound sort of aggressive when I'm talking. That's just my manner. Please don't take that I'm being aggressive. I'm passionate, not aggressive. Innovation, the world changes. I read a book about Elon Musk recently. When he started Tesla and SpaceX, everybody said he was crazy. Now, he started PayPal and they said he was crazy then. And then he starts Tesla and they all think he's crazy. Well, then SpaceX, they all kept saying he's crazy. But the world is changing. The internet came along in the 90s. We wouldn't even be talking now if it was not for the internet. So the world changes. And I think in this space of waterproofing, it hasn't changed as much as it should have. And the fact is there are now problem-free, and I stress problem-free because we all don't want the problem landing back on our desk, lifetime waterproofing. It is a reality and has been for a while. Now, what's giving us this reality? Liquid CSH, calcium silicate hydrate, liquid CSH, okay? That is the short version, sprayed onto cured concrete, liquid CSH, and that's what we're going to be talking about. What does it do? What does this technology do? It reacts with the calcium and the water, the calcium in the concrete and water, to form a calcium silicate hydrate gel. Now, among other things, it seals static cracks in the concrete, and in one case, up to 2.2 mm. Although there are limited products available, very few, but they certainly don't all do that. But in one case, up to 2.2 mm, and remain active in the concrete to seal future hairline cracks that may develop. And that might be 5, 10, 20, 50 years from now. Now, that's subject to the design mix, and we will come back to that later. But that's what the technology is doing, reacting with calcium and water to form a calcium silicate hydrate gel. So how does it work? Liquid CSH plus calcium plus water forms a calcium silicate hydrate gel. So penetrates into the concrete, forming a barrier in the top, generally about 15 to 20 mil, depending on the MPa of the concrete and so on, and seals the cracks in the concrete. So let's look at this in practice. Now, this is representing calcium acetate is representing the calcium in the cement plus water. So two of those three components are in that one bottle there. But that's representing the calcium and the water. And by the way, the guys at Kimu would be very happy to come and demonstrate this to you. And here is the liquid CSH about to be applied to there. Now, as I was saying, the guys at Kimu can come and do this actual demonstration in your office if you'd like them to. So you see it with your own eyes and you can feel and touch this stuff. This is what's happening inside the concrete. Now, we say an instant reaction. Sure, that's happening instantaneously, virtually within a few seconds, but it doesn't finish there. It continues to grow for 60, 90 days. In fact, it continues to grow forever inside the concrete, but the first 90 days is the real thing. And it becomes a glass hard gel inside the concrete. And as you saw, water is one of the components. It loves water. People have said to me, oh, well, we're in a tropical area, there's all this rain. That is good for this type of technology. Where this technology struggles is in, say, Central Australia or Riyadh in the centre of Saudi, where there's no moisture, no humidity. It wants moisture, which is, it works beautifully in the water tank for that reason. So that's what's happening. Later on, scan the QR code if you want the guys at Kimu to come and demonstrate it to you. Now, let's have a quick overview of the application. The material is suitable for use on properly vibrated structural concrete, minimum 20 MPa. It is designed to be used on structural concrete. That's simple. And it's sprayed on to dry cured concrete, as we'll show you in a sec, with a low pressure sprayer. During the curing, it's watered in once daily for the first 3 days. And when I say watered in wet season, if it rains, that's fine. It does the job for you. It's not rocket science, that process. It's just water. And you can see here on the left, this is a car park application in the US, where the guy is spraying the product there. Later on, one of his colleagues is watering it in. After it dries, you water it in. So that's what's going on. It can be used on horizontal and vertical surfaces. That's a big water tank. And here is the liquid CSH being sprayed onto concrete. Very simple application. And that is one of the beauties. It is simple. Good products are generally simple. Now, if you look at where it's been sprayed, it's very easy to see where the product has been applied. Okay, it's clear as day to you that it's been applied onto that structure. And it just doesn't get any easier than that. Now, there's a couple of other advantages of this, both for you as designers, but more particularly for your client. It's super fast application. One person can apply about 6,000 square meters in a day. Now, we've got to do a bit of prep work, clean up the concrete, as we'll talk about in a minute, blow the dust off it and stuff. But the actual spray application, 6,000 meters in a day, that's with a Honda pump. Compare that to a traditional membrane of 50 to 100 meters in a day. I mean, it's light years away from one another. Now, depending who your client is, let's say it's a developer. At the end of the day, it's an investor, isn't it, of some sort. He's putting up his money, but whether it be the, excuse me, the government or a private thing, and he wants is conscious of money. Look at how this plays out. Now, this would be a big project, like a bridge project. If you've got 100,000 square meters, and just obviously they put more labor onto it, but just in terms of man days, at 70 meters a day, taking an average of those, that works out 238 weeks, nearly 5 years. This poor bloke's been out there waterproofing this bridge. He'll have died of old age before he finishes. Now, with the Liquid CSH, that same guy is finished in 3 weeks. Like, it is light years away, and that is a big thing. We talked before about innovation, the world changing. Well, speed, the world's speeding up. This is relevant. And to a developer, it's very relevant. Now, here we've got a rooftop project where much smaller area, say a car park, a typical rooftop's maybe 1,500 square meters, say a car park or a big roof, 6,000 square meters. This same poor bloke has been out there for 12 and a half weeks if he works 6 days a week. The guy doing the Liquid CSH is finished in a week. So it is a really big thing to speed up a project, and that has serious benefits for your clients. Look at now the concrete design for a second. Concrete must be 28 days or older, probably 21 is fair point. 21, you can do it a bit earlier, but something like that. The surface must be clean, must be dry, free of dust, and anything that will retard penetration into the concrete has to be removed. Pretty simple. Like, it's simple. As I said earlier, good technology is simple, and ordinary Portland cement is preferred. We'll come back to that in a few minutes. Now, look at the typical areas for application. Liquid CSH withstands thermal stress, so it's particularly suitable on big areas of exposed concrete. And I should just add, where all crystalline products fail or are at risk might be a better way of saying it. And we, just so you don't think I'm being biased, we have a crystalline product of our own. So I'm not being biased, but the manufacturers, all the major manufacturers of crystalline, if you get to the bottom line, say it is not to be used in areas of exposed concrete unless it's thermally protected. Okay, so that is just, and that doesn't mean that's what people do. I've seen jobs leaking in Putrajaya that are leaking like a sieve that were done with a crystalline, but it wasn't in that particular case. And obviously I'm not going to mention company names, but it wasn't the recommendation of the manufacturer, because I've seen their website and they're saying don't use it like that. But that's what will potentially happen. So in this Liquid CSH, car parks, rooftops, bridge decks, wharfs, which a surprising number of wharfs have, call it concrete protection. Don't call it waterproofing if you prefer. Shopping centres and water tanks. We'll just skip through a few very quickly. Car parks, perfect application. Rooftops, shopping centre rooftops, car parks, double as a car park. I know you've got plenty of those in Malaysia. Podium areas, resorts, pools, green roofs, apartment buildings, and drinking water tanks. The products, the technology, this sort of technology is approved for drinking water in most countries. And wharfs, again, this is concrete protection, call it what you will, concrete protection, waterproofing. Now, why use it? As we said earlier, it permanently seals static cracks, in some cases up to 2.2 mm, depending on the particular product. Okay, and once it's sealed, it stays sealed. Now, in addition to sealing existing cracks, and I want to make this very clear, it will seal an existing crack and that will stay sealed indefinitely for the life of the structure. Okay. Now, as well as that, subject to the mixed design, it will seal future hairline cracks as well. Now, in saying that, as far as the future hairline cracks go, it is subject to the mixed design. There shouldn't be in the mixed design type F fly ash, or no significant amount of it, no more than 8% silica fume. On the other hand, GGBS or slag is really rich in calcium and is fine with liquid CSH. The reason for this, and let me say again, it doesn't matter what the mixed design is, the original seal of the existing crack will stay sealed indefinitely. This bit about the future hairline cracks applies only where you have fly ash and so on. And the reason is simple. Go back to the demonstration, and we said what you need for liquid CSH to work is you need the product, you need calcium, and you need water. Well, when you put fly ash into the concrete, after several years, it sucks all the calcium out. It uses up the calcium, okay, until there's none left. And you've probably all seen jobs done with fly ash where if it cracks underneath, in the old days, the concrete would just seal up with calcium, autogeneous healing, as concrete was designed to do. Now, if there's fly ash in there, that doesn't happen. It just rusts. So that's kind of the risk you run by fly ash. Now, incidentally, because we, or I, on behalf of the company, operate in many countries, and we see lots of trends around the world. The trend is, incidentally, is away from fly ash towards slag. More and more countries are putting in slag rather than fly ash. And that trend you would expect to continue. The use of coal is, fly ash comes from coal. It's a dead industry. It's on its way out, but that's another story. Okay, so why use it? Waterproofs for the life of the structure. We talked before, or I talked about designing a building for 50 years and designing the waterproofing for 10. Doesn't make sense. This will give you compatibility of the structure and the waterproofing. Withstands thermal stress. As we said, it can seal cracks in one case up to 2.2, and few other things. It increases the bond of concrete to other cementitious materials by 80% and withstands unlimited hydrostatic pressure. Now, we'll talk about application a little bit. It's a simple one-coat application, minimises human error. If you go back to what I said about membranes are inherently fine. You put them down in a lab in controlled conditions and everything else, they'll do a fantastic job for you. There's nothing wrong with them. They're fantastic. The problem is they're not being put down in the lab. They're being put down on a building site and all that goes with that. And as architect Abu Zarim said earlier, I used to work in swimming pool building, and I know what goes on in these building sites. And membranes, for example, are meant to really wait 28 days after a concrete pour to apply them in most cases, depending on the exact membrane. That never happens. If you ask people, I'd say 99 people out of 100 wouldn't know that's even the case. They're waiting for the humidity to come out of the concrete. Never happens. They just put them down. They finish it today. 3 days later, they're putting the membrane down. So all these issues come from human error, not fault of design, not or contracting issues, I should say. And I'm not criticizing contractors. They're under pressure to get the job done. But human error, this is almost error-free. No future reapplication or maintenance costs. And by the way, it's generally very economical. Now, this technology is very contractor friendly. Can't be damaged by other trades. Let me give you an example. I was in KL 7 or 10 years ago. I'm sitting with an architect and we're talking about software. We look out the window. There's a building across the road. The podium had a membrane all applied with some form of membrane. And the building was only on about the 4th level. It was going up to 30. Somebody had dumped scaffolding all over it. And we just laughed. We went, well, that's destroyed already. The building's got 20 floors to build and the waterproofing is never going to work unless they rip it off and start again. It's failed, right? That's just what happens. That's the reality of building. Saving manpower. Now, This at the moment is a big issue with COVID. We said earlier how one man can do all this work, 6,000 meters a day. I haven't worked out the figure, but I'd say you probably require 5% of the number of men on site that you would require to put down a membrane. So the manpower content is very, very, very minimal. Now that saves labor cost, which is a big thing in a high labor cost country like ours here. But at the moment, it means you can get a job done very quickly without worrying about manpower restrictions. It really is a big thing in this market. Now, the superfast application speeds costs and accelerates the project. You know that. It's very environmentally friendly, non-toxic, no VOCs, suitable for drinking water, does not create landfill. And it forms part of the concrete. It doesn't even have to be recycled. Now, that's why these products are approved, these technologies are approved by the United States Green Building Council, and they are the operator of the LEED program and will get LEED points in the correct project. It's not just every component has to come together in those projects, as you know, which will get tax deductions usually for your client, which he'll love you for, and potentially a higher resale. Now, there's no loss of slip resistance for cars driving on it, protects against chloride ingress and so on in these wharf situations. And there's plenty of this sort of thing being done, concrete protection. Don't call it waterproofing. Now, it actually will make, in certain cases, the concrete harder than granite. One goes up to 9 on Moscow. Diamond is 10. It's as hard as you can get. It'll make it harder than granite. Now, you don't need a screed. Now, I want to make a point here, which you may or may not like, but anyway, I know in Malaysia, people have said to me over the years, oh, but we need the screed to get the levels. The buildings are poured flat and we need the levels. And they say the same thing in Indonesia. Now, the screed is there for 2 reasons: protect the waterproofing and get levels. But I also spoke to the head of construction of one of your major developers, and I'm not mentioning any names. Even if you asked me, I wouldn't tell you, but one of the major developers in Malaysia. And in this conversation, somebody said to him, oh, but you can't pour the fall. He said, that's complete rubbish. I've been pouring the fall for 30 years. And he said, it's not hard. They're just too lazy to do it. And you think about it, when in my swimming pool building days, I built a tennis court for somebody one day, and I didn't realize till I looked at the plans and everything, oh, it's got a fall in it. I thought a tennis court, I'm a tennis player. I thought it was flat. I didn't realize that Pete Sampras was hitting uphill half the time. A tennis court falls one foot end to end. They pour that to fall. Every tennis court that's ever been poured has fall in it, I guess. So it can be done. It's not difficult. These contractors just get away with murder in some cases. And by the way, I'm not criticizing contractors. I was a waterproofing contractor, right? So I'm not saying that. But it's not that hard, but nobody's pushing them to do it, so they don't do it. You get rid of the screed, saves you time. Your client, the developer, will love that, right? Saves you the cost of the screed, which in many cases is like 2/3 of the cost of the waterproofing, and it saves you weight on the structure. There is no need to have a screed. And look, I'm not saying that we do everything perfectly down here, because we absolutely, positively, definitely don't. But every building built in the last, I don't know, 30 years, they would have poured it to fall. It could be 50 years. It's not that hard. It really isn't. So now here's another really good point. You know, I keep saying there's no problem with membranes per se. It's the practical differences that are the thing. Now, this is a building site. I took that photo myself. With a liquid CSH, it's virtually impossible to damage. It doesn't need a screed to protect it. And it's trafficable, by the way, in a couple of hours or 2 to 6 hours. Now, you could have sprayed the liquid CSH a few hours ago and put all this stuff down and it won't affect it. In fact, you can put it on it when it's wet and it won't affect it, but it's not ideal, but it's not going to damage it, right? You do that to a membrane, forget it, start again. You just dump that. Remember, with a membrane, what you have to do is find the source of the leak. That's the problem. And I'll give you a personal example. I lived in a little apartment not far away down the road here when I was younger. We got a leak. We're on the bottom floor at the back. We got somebody in. Eventually, they traced it to the second floor apartment on the other side of the building, and it leaked all the way through. That's what makes it hard to fix. You've got to find the source of it. You only need a pinprick and you've got a problem here. Now, if you got a jackhammer and jackhammered through that concrete, of course, you're going to get a leak. And that's happened. It's a building site. That's happened to us. But you know where the leak is coming from, that's where it is. That's the problem, right there. You don't have to walk around 100 metres up the end of the building and hope to find it. So it's virtually impossible to damage. But if you get a bit excited with your jackhammer and you do damage it, it's very easy to fix. And so what I'm saying to you over and over, I guess, is that the problems with traditional methods is they're great theoretically, they're not great practically, and that's half the problem. Now look at this. This is a ponding test at the Dialogue Hotel in Bali. This is a building, that's the roof of the building. So they've waterproofed it. They've now ponded it, put all this waterproofing, water, I should say, on the top of it. And when you go down under the building, not a drop is leaking, right? When I was sent that thing at first, I thought, geez, what's this, a water tank or something? I had no idea what, I saw that, I thought, is this a water tank? That's the rooftop of a hotel. So, and it's a great way to test it, by the way. So that can show you how well this technology can work. And in case you're getting bored, we're not far off the end. Okay, let's compare liquid CSH to traditional methods. It's got a longer lifespan. It's simple, longer lifespan. It's problem-free. And I want to emphasize that word problem-free. None of us want problems. Do you want people coming back to you and going, oh, my waterproofing's leaking, you know, get it fixed. How did you recommend that? And all the rest of it. None of us want problems in our life, right? We want problem-free, and that's what this can give you. Now, I should say, however, don't get the wrong idea. I am not saying to you that this is magic spray. And a guy said this to me in India. We're up on about the 40th floor of the Four Seasons apartments they were building, very upmarket apartments. I mean, very upmarket, very expensive. And we're talking about all this stuff. And the guy says to me, so this is not magic spray. I said, no, it's not magic water. It has limitations like every product. You can't just stand here and spray it off the 40th floor and the whole of India is waterproof. Don't get that idea. And it's funny how people go from one extreme to the other. First, they don't think it'll do anything and they see it work and then they think they can spray it anywhere. It is not magic spray. It has to be used correctly according to what you're meant to do with it. And if you do that, it's very simple and it works beautifully. But if you start thinking you can waterproof the whole of Malaysia, wrong. It's got to be used on the right job and then it'll work perfectly for you. But it doesn't have all these inherent problems. It can't be torn. It doesn't have layers of adhesion, all this sort of stuff. So it eliminates most of the traditional application issues. And we've talked before about it, crack sealing and environmentally friendly and all that. Certainly, you can never call a traditional membrane environmentally friendly. Most of them are made from oil-based products and end up as landfill. That's not exactly environmentally friendly. So let's move on now and say, Why adopt the new technology? Well, that's a good question. And for each of the major parties involved in a building, why adopt it? Well, first of all, I would say to you, if you don't move forward, you move backwards. That's just a philosophical point. If you don't move forwards, you move backwards. Nobody wanted to adopt electric cars. Now they're talking I think in Europe, in another, is it 15 years or something? They're going to ban traditionally powered cars. I might be wrong on the time frame. It might be less than that. Even China, I've been to China many times. Electric cars are starting to become a thing there. You've got to move forward. So what advantages does your client get? And remember, if you're working for a client, you want a happy client, just as we do, because any business worth its salt wants repeat business. If you don't deliver on your promises, you might get a sale, but you're not going to get a second sale once they realize that you've been dishonest or you're not delivering. You've got to deliver. You want to give your developer, your client, what he wants. Now, he gets advantages from all these things. Super fast application. Don't underestimate that to a developer. It is a key issue to a developer. It mightn't seem very important to a developer. That is a major, major thing. So within the time frame and the budget, that is what a developer thinks. On time, on budget, and hopefully ahead of time and ahead of budget. Now, I'll just do I'm not going to go through all these figures with you. It looks a bit messy, but I did a presentation to a developer once, and it was probably 5 years ago, the one I'm thinking of, more. And I went through the speed of application, and I said, how much is this building costing? Let's just say it was 200 million. The interest component was the big thing. In this scenario, cost $830,000 a month in interest. Now, without going through all these things, but look at the time it takes to do your traditional, look at the time for the new technology and the saving, and you know where it finishes up? You save your client 2 months, and at 830,000, I'm talking Australian dollars, sorry about that, you've just saved him $1.5 million. Now, people say to me, and you can convert that to ringgit if you want, but whatever, say that's $1 million US. That is how developers think, believe me. I used to do work in the construction industry for the second richest man in Australia. He was the biggest developer here, and he was the second richest man. And people used to say, oh, his apartments are second rate and all this sort of jazz. But I'm telling you now, he made billions, I mean billions and billions of dollars, and all you ever heard from him was speed, speed, speed. Get the building finished, right? And you present that to a developer, they will love you. And people quibble over the cost of waterproofing. One's 20 ringgit and one's 21, and they fight you over it. Like, that's the key issue. So what's the benefit to you? The advantage, the benefit to you? Problem-free, lifetime waterproofing for you and your client. And that can benefit your reputation. First of all, lifetime is a sort of an abstract concept that, you know, who cares really what happens in 50 years, really? Who cares? I'm in another job, I've moved on, I could be living in a different country. I get all that, and that's fine. I get all that. But if you can give them that and it doesn't cost them money, there's no big downside, why wouldn't you? Why wouldn't you give your client that if there's no big downside, right? Now, as for problem-free, that's got many aspects. Do you want somebody coming back to you and dumping this problem on your desk? Oh, you designed this product and now it's failed, the building's leaking, the shopping centre's closed, and in the worst case, we're going to sue you, and all the rest of it that goes with it. Well, it probably doesn't happen as much as it happens here. Nobody wants that in their life. You want problem-free. Go and do the job, make my life easy, don't give me problems. That's what we all want underneath. So, and I'll come back to superfast just for 1 second. We keep talking about it. In Australia, I don't know about in Malaysia, but in Australia, some designers are actually get a bonus if the project is delivered on time. And a significant bonus, significant, as does the project manager, I might add, on the job. So there's a lot of personal incentive beyond just the moral incentive of helping your client to get it right. You may well get a personal benefit, or the company anyway. How that's split up is another issue. Now, for the main contractor, simple, super fast application can help him avoid liquidated damages claims, enhance his reputation, and at the moment, less people on site, less manpower. If I'm right, the restrictions are allowing, I think, 30% on manpower on site. I could be mixing that up with the Philippines. You can get a waterproofing job done with this sort of technology like that, right? With hardly any manpower at all. If you've got jobs out there where people are now struggling because they need, we talked about the poor guy doing the membrane, it's going to take months, but there's a team of them realistically, aren't there? There might be 5 to 10 of them. Now they can have 3. Well, what's going to happen? Your project will get delayed. You go out with this, you hardly need any manpower whatsoever. In COVID, there is no better solution from that point of view to solving that issue than a liquid CSH. It's just, there is no comparison. I mean it, no comparison. And I thought my throat was getting a bit dry. So that is a good thing. We've got to the end. Here again, if you would like to claim your free seminar kit, Kimu are more than happy to come out, send that out to you if you scan the code, and you can do so there, and they will do that. And by the way, just while we're talking, if you want Kimu to come and demonstrate that process to you, as I said earlier, they're more than happy to do so. When you see it in the reel and you can touch it and feel it, it has a lot more meaning to it. You can do it yourself. It's not rocket science. And if you've got any queries, of course, you're always welcome to send me an email. And hopefully one day when COVID has diminished a bit, I will be back up to Malaysia and hope I meet some of you personally. I was actually there in March, and then I went over to the Philippines, got out of there the day they were locking down, and arrived back here the day they locked down. So I'm not used to being stuck down here for so long. I would love to come and meet some of you personally. Now, I think it's time that I stopped talking so much and throw it open to whoever wants to ask a question.
Okay, thank you very much, Michael. Very interesting, very informative. Okay, and yeah, a lot of things. I was hoping you'll touch a bit on your flying, but anyway. All right.
You can't get me started on the flying. I won't stop talking then. If you think I've talked a lot then, if you talk to me about flying or travel, I'll still be here in 5 hours.
Okay. Maybe another time.
Another time, yeah.
Okay, then. I can see there's a lot of question that has been put up in the Q&A chat. Maybe I'm not sure how to go about this, whether Mr. Fanis is going to answer some of that. I think he has actually mentioned that some he wants to answer live. Maybe we can give him that chance.
Okay.
All right. Fanis.
Hello to
All right,
everyone.
over to you.
Hello to everyone from Athens in Greece, in Europe. I will be very happy, together with Michael, to answer some of your questions. Several of them I have answered already by typing, but some of them either I didn't have the time or they arrived at the last moment, so we can discuss them live.
All right. Okay. Yeah, maybe we'll just go through some of them. Okay.
So let's see what we have here. I'm starting for the last one that came in. The question is, does the product come with warranty? For how long? Manufacturer's warranty? Can we get another contractor to apply the waterproofing? Or is there a requirement for an in-house contractor for the manufacturer? Okay, well, actually, as Michael said earlier, the products which are actually representing this technology are less than the fingers of one hand. Okay, there are very few. Talking about our own product, you can talk to the sponsor of the event, which is Kimu, and the distributor of CWS in Malaysia. The product comes with 25 years of warranty. There are very few products around the world that do have a 25-year product warranty, meaning it's not going to fail on year 26, but probably it's going to last for much more. Well, you can get any other contractor to apply this technology, provided they have been trained by Kimu and they know what they are doing, so that you can enjoy the full lifetime waterproofing that this technology can offer to you. Okay, let's move on. I'm going right from the start. How does it perform under solar exposure in the tropic? If it's exposed to acid rain, will there be decay? Okay, first of all, this was a technology that was designed to withstand thermal stress, and it is ideal for areas which are exposed to thermal stress. So it can be rooftops, wharfs, bridge decks, podiums, balconies, and areas which are exposed to thermal stress. Several of you had asked me earlier about crystalline waterproofing, and I had already typed in some answers. So for those of you who have not read it, crystalline waterproofing is fantastic technology, but has a certain weakness. In areas exposed to thermal stress, where the concrete may be expanding and contracting from day to night, or imagine a rooftop which is partially between two high buildings. Okay, it's partially in the shadow, partially in the sun. As the sun is moving, so the exposed part is moving as well. This expansion and contraction cause the crystals to become brittle and break. Okay, so this technology will not have the same behavior. It is designed to withstand thermal stress, and there's not going to be any problem. Now, talking about acid rain, one might ask himself, well, how acid are we talking about? If it's acid enough to destroy concrete, then you don't have to worry about your waterproofing, but about your whole rooftop. Okay, but if it's the normal acid rain that, like we are getting in Greece, probably most of you may know the Temple of Acropolis, the Parthenon. Because of the carbonization of the free carbon dioxide in our bad atmosphere, together with water, we are getting acid rain, and this is eating away the calcium marbles, okay, the marbles of the Parthenon. So similarly, if this is decaying for the concrete, then the concrete will suffer. Don't forget that this liquid CSH is the same chemical structure as concrete. So whatever your concrete is getting, the same thing is happening with the material. However, because it blocks fully the capillaries, the porosity of the concrete is going to protect your concrete from the chemical attack. Can it be applied directly onto existing screeding with hairline cracks on traditional brushed on waterproofing? Technically, yes. Well, as long as your screed is made out of concrete and there is free calcium, technically, yes, you can apply it. However, remember that you get the best behavior out of structural concrete that has a strength of a minimum 20 MPa and above. The truth is that screed rarely has this kind of strength, and actually, because screed is not meant to withstand big loads, and it's actually meant to protect the heat insulation or the traditional membranes, which are there. If for any reason your screed cracks, well, there goes your waterproofing. It would not be advisable. If you would like to use it there as a double safety, having already applied it on the concrete slab, then yes, this is a very viable solution.
And could I just add something to that? Yeah, if the structure of the screed is such, or you said brushed on waterproofing over the top of it, if it holds together for years and years, so will the waterproofing. So will the CSH. We just have seen so many screeds break up because they're not well constructed. That's all we get to. Well, why put it on something that's about to fall apart? So that's the only point. Yeah, technically it works, as Fanis said. Sorry, Fanis, I'll shut up now.
Okay, no problem. We have another question here. Hold on, let me, please excuse me for a moment. Other than concrete with fly ash additive, what are the reinforced concrete structure that is not suitable to be applied with LCSH? Well, one case that really comes to mind, and we should talk about it, is steel decks in areas where you might have a concrete slab which is applied on a steel deck. You should be aware of that because steel decks, they have quite a lot of flexibility, and that might cause your concrete to crack anyway and produce dynamic or volatile cracks. So it's not advised to be used on steel decks. Do we have one more question? Do we have, excuse me, to remove the screed in an existing building with leakage problem? Well, actually, yes. You know, the leakage problems are really devil's work. You might see from below your rooftop that you have a leak someplace, but that doesn't mean that the leak is coming right on top of it. It could be coming from as far away as 50 or 60 or 100 meters across the slab, just because the part just above your head was the weakest point and the water appeared from there. You cannot detect and make a real repair unless you remove the screed, make sure that you have found the source of the leak, the crack, and you apply the technology properly to fix it. Okay, how to solve with your waterproofing if the crack line is more than 2 millimeters width? Well, actually, this liquid CSH technology is not a crack sealing technology. So the products based on this are not crack sealing products. There are dedicated crack sealing products that do an excellent job. It is a waterproofing technology that has crack sealing ability. So if you have a crack which is more than 2 millimeters width, it can be 3, 4, 5. Actually, you might need a dedicated crack sealing product, let alone that if you have a 4 or 5 millimeters crack, then you have much more serious problems to think about on your structural concrete rather than the waterproofing. So generally, the idea is that you would have to use a dedicated crack sealing material. How about the anti-root properties for landscape decks? Interesting questions. Okay, we had, well, distributors and clients of our distributors around the world have been asked the same question because it's being applied on green rooftops, and normally people are expecting to see a root-proof cloth to be applied there. This technology is a root penetration proof. It can be applied directly on the concrete, and you don't have to think of using similar root penetration cloths to do that. Can it apply on floor tile surface? Well, as was explained earlier during the presentation, we apply this technology directly on concrete and not on tiles. Okay, what are terms and conditions that would render the warranty void? Well, bad application that does not follow the rules of applications which are set for authorized and trained applicators. Please refer to Kimu, who is the authorized distributor in Malaysia, for more details that they can help you with. Okay, hi, I joined late and missed a few things. What CSH stands for? So it is calcium silicate hydrate. It is the general structure that concrete has. Okay, can you apply it upside down under the leaking floor slab, under another toilet? If I understand well, you're asking if we can apply it on a rooftop from below. Well, actually, no, we apply on top of concrete. And in that case, we not only have the capillary phenomenon, but the gravity as well to assist the penetration. So it is advisable to apply from the top of the concrete slab. Do we need to engage your applicator, or we can do it on our own? Well, actually, this is an application that requires quite some training, knowing the details of the behavior of the product and how to properly apply it. So please refer to the CWS distributor in Malaysia, which is Kimu. Prices, okay, you're going to discuss them with a distributor. What area can it cover? Well, a general rule of thumb is that 1 liter of this technology should give you, well, depending on the product, but if we are talking about our own, that should give you roughly about 5 square meters, depending on the finish of the concrete surface. If the finish is rougher, you might get a little more. If the finish is much better, you might get 6 or 7 or perhaps a little more square meters for 1 liter of product. How does it react to sun exposure, expansion and contraction behavior against Portland cement? Well, this product, as I said before, was designed to withstand thermal stress. So it reacts excellently to sun exposure. It will protect the concrete, and as long as your concrete is not being destroyed by temperature, so will the same product will behave in the same way. If we take it to the extreme, and some people would tell me, what is its resistance to fire? For example, if the temperature would be 500 or 600 degrees, then I would say that since about 300 degrees centigrade, your concrete is already losing its strength and being destroyed, the same thing is going to be happen to your waterproofing. Okay, more questions. Here I have a threefold question. Somebody says, my experience in selecting the appropriate waterproofing in a project in the Maldives in 2010, our engineer used fly ash to address the trenches for underwater submarine cables. In a rooftop for a huge flat roof in 2011, where it was only for human traffic, we used Sarnafil exposed membrane as it was chosen over the typical sandwich system because the technology based screed protective screed because the technology was not available. In a project where the design called for deep basement, with 25-meter for high hydrostatic pressure, we used admixture applied on the top, 300 millimeter at the basement. So questions, can this liquid CSH technology be used in the future to repair these 3 types of application? Well, one of the applications that I mentioned earlier were underwater submarine cables. So remember that we apply this application on dry cured concrete, so we would not have been able to use it under the sea. The second had to use on a rooftop for a huge flat roof where it was only for human traffic. We used Sarnafil exposed membrane. Well, membranes, as Michael said earlier, is good technology. Okay, it's good technology, and they could live for quite a long time under laboratory conditions. However, these are not laboratory conditions. We're out in the streets, we're on rooftops, we're on hard weather conditions, and this is why those materials break. However, on that rooftop, you could have perfectly used this technology without the need of membrane on top of it, and even without the need for the protective screed for the membrane. Okay, let's see if we have more questions. I see one coming in right now. It said, you address how to stop leaks or water penetration, but most of the cracks in concrete may be due to the rust in reinforcement. So how about spraying CSH direct onto the reinforcement steel prior to pouring of concrete? I remember 40 odd years ago, we used to tell the contractor to ensure that all steel bars are painted with cement slurry to prevent rust. This practice has been ignored over the years. So first of all, let me remember that CSH technology needs the free calcium to operate with and water. So if we apply CSH directly on the steel prior to pouring, then actually we probably might not have the same kind of reaction passing in. And also don't forget that if the rust has already happened, then it is too late for us to apply CSH technology on top of the concrete. It has already happened. So it's not a corrosion inhibitor as a product. It is a technology that is indirectly a corrosion inhibitor because it does not allow water carrying soluble chlorides and sulfates that will eventually get to the rebar and cause a corrosion. I don't know if we have any more questions. Can be applied? Yes, we have. Can it be applied to vertical concrete surfaces? Absolutely. As you may have seen on one of the pictures of Michael's presentations, we can absolutely apply it to vertical surfaces, similarly to horizontal ones. And this is why it is a product which is ideal, a technology which is ideal to apply on water tanks, on storm water collection tanks, water treatment tanks, and similar. Okay. I don't see any more questions coming there. Somebody says we want problem-free. Yes, we are with you. We want problem-free. Everybody wants problem-free. And this is why we're all moving to better technologies, to better applications. Okay, for the restaurant, does the gel suitable to apply on all the kitchen floor slab as a waterproofing system before applying the monolithic seamless flooring? Okay, in a similar way, we had been asked some time ago about using it in a meat factory where the fats, the greases of the meat are really very aggressive on the concrete. Well, as long as the materials which are falling on the concrete are not detrimental to the structure of the concrete, yes, it will help enormously. Perhaps in some cases where you might have very aggressive materials, you might have to think perhaps of applying on top a self-sacrificing material, which may be periodically surveyed and substituted. Have you tried it on saying new steel bars right at the steel factory? Will that help? Well, it will not help because we need calcium for the material to react with and water. And just applying it on steel bar would probably have no effect. Okay, how long has this product been in the market? Well, actually, this is technology that was invented quite a few years ago. And at that time, nobody could think of an application of how to exploit it. And later on, it was discovered that if it is applied on concrete, then together with calcium in the concrete and with water that we applied with external watering, it gives to the concrete this kind of waterproof properties that today it has. It has been in the market for quite many years. Do we have any more questions?
Okay, I think you have answered most of it.
Thank you very much.
Right. Okay. Thank you very much, Panis. And I think I'd like to bring it to a close. But before I do that, maybe I can get Panis just a quick 1 or 2 minute wrap up on all the various questions that's been asked. Over to you, Panis.
Yes, please.
No, I mean, would you like to wrap up based on the questions that has been made? You know, summarize a little bit. Yeah.
Okay. So what we are talking here.
Panis?
Yes, you cannot hear me. Okay, sorry. Okay, so this is a technology which, although it was designed quite a long time ago, it started only rather recently to be widely acknowledged against the natural resistance that we all have to new materials and new technologies and new kinds of application. This is a technology that, if properly applied, can essentially double the service life of a construction building, protect it against chloride ingress. Let us not forget that the extra properties that it offers to the concrete, like increasing the concrete hardness to 9 of Mohs scale, so it's much harder than granite, because granite only comes in at a mere 6 or a 7. The protection of the slip resistance, but mostly the super fast application at 6,000 square meters per day per applicator means that we're essentially fighting against the COVID imposed restrictions on construction sites, which are really hampering and impeding the construction process. They are delaying the projects and are really affecting not only the construction speed, but also the properties of the developers that are starting to bring income, and also affecting the construction industry as a whole.
Okay, thank you very much. Okay, that's a wrap up from Mr. Fanis. I'd like to finally close the thing with Mr. Rorke. Maybe you'd like to summarize what you have said and, bring the thing to a close, and I can formally close it.
Okay, thank you, Architect. Yes, well, firstly, I would again like to thank everybody for attending tonight. There's probably more fun things to do in life than listen to me, but anyway, that's how it is. So thank you to everybody, and thank you, Architect Zarim. And look, in summary, we believe waterproofing should be problem-free and should, as far as possible, offer you lifetime waterproofing. It's a bit of an abstract concept, but do it once, get it right, and move on with your life. You guys don't want problems on, ladies and gentlemen, that's my Australian slang going again, don't want problems landing on your desk. So that's what you want to do. Do it once, do it right. Think about new technology. The world's changing. The internet changed the world. These guys, electric cars and all the rest of it. And people are hesitant to change. But in this case, there is virtually nobody I've ever met in the world that has said to me, well, there is nobody that said, oh, yeah, all this waterproofing is great. You'd never change it. Everybody knows it's not that great. And yet they resist change. Some don't know about the innovations and some resist change. That's fair enough. Not everybody likes change. But can I say to you all, please examine it, make your own decision. Don't just write it off. That's what I would say to you. And we respect whatever decision you come to. And thank you again, Architect, and to everybody.
Okay, thank you very much. So for both the speakers and Mr. Rorke and Mr. Fanis for answering most of the questions that have been raised here. And to Mr. Rorke, is very, very enlightening on how the technology has actually given us architects here and the rest another alternative product to look at. And before I finish it off, I would like to say maybe we will invite both you and Mr. Rorke on a later date to talk about your flying, as well as the beautiful green Greece mountainside that you have just shared with me earlier. Okay, so yeah, that will be something different, So until then, thank you very much, and also to our company, the company Kimnok, okay, for agreeing to sponsor this project. All right, then. Okay, thank you very much. Everybody have a nice and almost weekend. Okay, it's almost weekend, so have a nice weekend. Stay safe. All right.
Thank you very much. Thank you, everyone.
Thank you.
Thank you for your time. Bye-bye.